George Gamow. Matter, Earth, and Sky. The symbol MeV stands for a million electron volts. An electron volt being the energy imparted to a single electron when it is accelerated by a 1 volt electric potential. Similarly, keV stands for 1,000 electron volts, BeV for billion, so on. The probability of escape of an alpha particle through the energy barrier erected by the high nuclear forces in the atom depends on the relation between the energy of the particles and that of the barrier, and these factors vary in some incompletely understood manner from one nuclear species to another. So, the nearer the energy of the alpha particles to that of the barrier, the more probable is the escape of any single particle, and therefore the more rapid the general decay of the nucleus. Thus, the decay constant of any given radioactive element depends on the relative energies contained in its nucleus. Lead-age methods. Defective methods and faulty interpretations cause erroneous results. Consider, for example, the various methods based on disintegration of uranium and thorium into lead. Each of the parent elements disintegrates by some process through a certain chain of elements and isotopes until it reaches a stable condition. Geochronological use of these facts requires very accurate measurements of the amounts of the various elements of the chain present in the mineral, and also very accurate knowledge of the radioactive respective decay constants. The techniques for these determinations are exceedingly difficult and subject to large error. Although radioactivity measurements of geologic age have been widely accepted for some 50 years and have been responsible for the wide acceptance of an age for the Earth measured in billions of years, it is now generally admitted that most of the work done before 1950 and on up to the present age was quite misleading, mainly because of defective measurements or interpretations of those measurements. Gordon Gastiel has recently reminded his colleagues, attempts to measure mineral age began soon after the discovery of natural fission. During each decade since then, analysts have discarded most of the age determinations made in the preceding one. And it still goes on like that. The distribution of mineral dates in time and space. These are really good. American Journal of Science. Really good publications. Qualified people. Bad answers. Original lead, not considered in radioactive age determinations, equals false conclusions. A more important reason for the errors in the early published ages was the neglect of the factor of original lead in a mineral. Obviously, if some of the lead in the sample was non-radiogenic, then the computed age would be too large by an indefinite amount, unless the common lead were first determined and eliminated from the calculation. Recognition of supposed common original lead depends on detection of lead atomic weight 204 in the mineral. Now, ore lead contains a small amount of this isotope along with larger but varying amounts of 206, 207, and 208 atomic weights. Each of the latter isotopes can also be produced radiogenically. However, the all-important amount of 204, lead, is quite difficult to determine accurately. G.R. Tilton points out it should be realized that the lead 204, Pb204 abundance is the least accurately known of all the isotopic abundances for the leads. So we have interpretation of lead age discrepancies. Now, all these older publications, I did this article years ago, yet it's still the same. What complicates things for the uranium lead method is that non-radiogenic lead 204, 206, 207, 208 also exists naturally. The scientists are not sure what the ratios of non-radiogenic and radiogenic lead were early in the moon, we're talking about moon rocks, history. The problem of how much lead was around to begin with still remains. If all of the age dating methods, rubidium, strontium, uranium lead, and potassium argon, had yielded the same ages, the picture would be neat. That never was and hasn't been. But they haven't. The lead ages, for example, have been consistently older. Isotopic ages have been obtained from material from 5 landing sites in the moon, those of Apollos 11, 12, 14, and Luna 16. Each site has a different age, but in a given site, the ages also vary. Ideally, however, any one basaltic rock from a given site should yield the same isotopic age, regardless of the method used. You'd think. The moon isn't older here and younger there. Science News. So leaching of lead or uranium results in radically incorrect age determination. Other possible sources of error are known to exist, of course, and have often been used as the basis for rejecting measurements which seemed incapable of harmony with the accepted chronology. Hahn indicates one possibility. It may be that part of the lead was leached out. Then, the age determined would be too low. However, it is also possible that uranium was removed. Then relatively too much lead would be found, and the age determined would be too high. It follows that reliable lead values can be expected only from specially selected dense material samples that are weathered as little as possible. Otto Hahn. The serious probability of significant uranium leakage is clearly shown by the following. So, most igneous rocks also contain uranium in a form that is readily soluble in weak acids. Hurley found that as much as 90% of the total radioactive elements of some granites could be removed by leaching the granulated rock with weak acid. That happens naturally. Larson and Fair note that commonly as much as 40% of the uranium in most fresh-appearing igneous rocks is readily leachable. The seriousness of these defects is also pointed out by Fall. Countless determinations have been made by this method, but it was found that the premises on which the method rests are not valid for most uranium minerals. There is definite evidence of selective uranium leaching by acid waters, which occur naturally all over the place, and it is not now known that most radioactive minerals contain some lead, which, when they were formed, natural lead. And we don't know which is which, at the point of there's some natural lead that can be everywhere, and also in the uranium sample that you're looking at. And maybe that part existed because it was separated physically. I mean, the rocks you're looking at have been around supposedly for millions or billions of years. As a result, most of the early, and for that matter all, of the lead-uranium age determinations are questionable. These are scientists who are on the side of an old Earth. Henry Fall. Dr. Patton says, the fourth assumption presupposes that the concentration of uranium in a specimen has remained constant over the specimen's life. You willing to bet your bank account on that? Millions and billions of years? Groundwater percolations can leach away a proportion of the uranium present in the rock crystals. Yeah, only it takes one rain. The mobility of the uranium is such that as one part of a rock formation is being impoverished, another part can become abnormally enriched. Right? Such changes can also take place at relatively low temperatures. So you got rain flowing through, a river flowing through, or temporary water flowing through, from one rock to the next. You don't know what's accurate and what isn't. Methods which compensate for shortcomings in the lead-age method fail completely. Don Patton. There have been a number of very diligent efforts to try to overcome these limitations to the accumulation problem, knowing how much there was to start with at the bottom, how much was leaked in, how much is leaked out, so on. One of those methods involves the isochron method, the whole rock isochron method, using several different dates that are supposed to plot mathematically along a straight line. If they line up in a straight line, then we're supposed to know that this is uncontaminated, nothing leaked in or leaked out. Well, the result is it just doesn't work. For example, in a recent example done by the Institute for Creation Research, dating the lavas in the Grand Canyon, up at the top of the plateau which was tested, there's supposed to be young basalts or lavas, young, not old, the bottoms are the oldest, that have formed over the lip of the canyon and down into the canyon and actually down the river, Colorado River, in some places. Obviously the youngest portion of rock, flowing over the edge. down into the river. However, down into the inner gorge, in the metamorphic rock, we have the Cardenas basalt, supposed to be among the oldest rocks in the canyon. Here we see a date that has been achieved at 1.07 billion years, and an isochron has been done. It plots along the straight line, and that's supposed to tell us that there is no contamination. But we go up to the top where we have the very recent lavas that flow over the lip, and we find a date of 1.34 billion years compared to the 1.07 billion years at the bottom. Now, wait a minute. Here's the youngest older than what's supposed to be much older at the bottom. And we do the whole rock isochron method on this date. We find it plots in a straight line with 1.34 billions, supposedly very precisely. And yet we know that cannot be so. The younger has the older, and the older is the younger. When you get to the proof of the pudding, so to speak, then you find that it simply doesn't work. Science magazine recently, there was an article called Pseudo-Isochron. 30 examples were given of isochrons forming straight line that we know from the physical evidence is not dated accurately, where you have rocks that are interbedded, laid down necessarily at the same time, which give widely different dates by hundreds of millions of years, but all date on the isochron. Wow. Well, the system of trying to determine which those beginning conditions then just doesn't work. What actually happens is illustrated in the quote by Richard Mulger from the Department of Geology at East Carolina University in Contributions to Geology. He says, in general, dates in the correct ballpark are assumed to be correct and are published. Yeah, what you think should be the ballpark. But those in disagreement with others' data are seldom published, nor are the discrepancies fully explained. They're just saying, well, it's not what we want. No, it's not what you want. That's the issue. It's what did you calculate. Now, this is how it works. You keep what fits, you chuck what doesn't fit. You unjudiciously select, if you please. Lead isotope methods are not accurate either. Another method consists of comparing the relative amounts of the two lead isotopes 206 and 207, which are present in the mineral. Actually, the method is subject to several errors. Loss of radon 222 raises the lead-to-lead ratio and the calculated edge. A rather large error may be introduced by the uncertainty in the comparison of the original lead. This error may exceed the measured value when dealing with younger uranium minerals, containing even small amounts of original lead, as clearly recognized by Holmes when the method was first proposed. It is common now to attempt to allow for contamination by original common lead by assuming without actual proof that the presence of lead-204 in the mineral indicates such contamination. Presence of old radiogenic lead formed in a prior site of the parent uranium may also cause great error. Many or most such minerals might equally well contain some contaminating radiogenic lead from some other source. If so, the age computation would of course be too high by a quite unknown amount. The possibility of this type of phenomenon occurring is indicated by a study at the University of Toronto. It says, there are some leads that have been referred to as anomalous, which have isotope ratios that do not at first sight seem to participate in this regularity. We believe that additional amounts of radiogenic lead have been added to these leads at or about the time of final mineralization. That is, an anomalous lead is simply an ordinary or non-anomalous lead which has been further altered. Given a lot of time, which it does have a lot of time given, that will happen. So, Farquhar-Russell, anomalous leads. The above authors, Farquhar and Russell, were concerned about the fact that too much radiogenic lead was present in certain supposedly ancient lead ores to harmonize with a false theory that common lead has been uniformly enriched during geologic time with increments of radiogenic lead, as is evidenced by the large proportions of lead isotope 204 in older common leads.